Alright, let's determine the equation of the slant asymptote of this function right here. And there should be a slant asymptote because the degree of the numerator is 1 more than the denominator, right? We have degree 3 in the numerator and we have degree 2 in the denominator. So the way you find the slant asymptote is by doing long division. Be careful, I see a missing term here. So we have 4x to the third power. There's no quadratic term. There's no x squared. So I'm going to put in 0x squared as a placeholder. Okay, and then we're back to plus 3x minus 8. So you take this first term underneath the symbol here. So we're going to divide 4x to the third power by this first term, which is x squared. That's going to give you 4x. So that's going to go right here, 4x. And then you take that and you do the distributive property with it. So 4x times x squared is 4x to the third power. 4x times 4x is 16x squared. 4 times negative 1 is negative 4x. But then you subtract by changing the signs. So minus, minus, plus. Okay, so these cancel out. Here I have negative 16x squared. This makes positive 7x, and I bring down the minus 8. Okay, and then you start over. So I'm going to take this down here and divide by this right here. So I will do negative 16x squared and divide by x squared. Alright, that's going to make negative 16. So that's what goes right here. Now I could keep going and take this and multiply and such, but I'm going to wind up with some sort of remainder down here, but the remainder does not get involved in the slant asymptote. So the slant asymptote will simply be y equals 4x minus 16, regardless of what the remainder turns out to be. So the answer is option number 2. Boom.